Okay, we are in a virtual reality experience called Visceral Science. This experience is dedicated to the topic of the formation and evolution of stars, formation of the planetary systems, and students can use this multiplayer experience to join from the virtual reality headsets and walk around the galaxy, create star systems, as well as join the experience from mobile phones and tablets and other mobile devices if they don't have access to VR. But in addition to that, they can join through video messenger and participate in the experience just as they would participate in regular video call. Now you can see that I as a teacher have a special panel from which I can control the call, and this panel has like a preview screen and all other buttons to control the call. For example, the buttons to control the camera. I can put the camera here in the manual move and move it around and show that I'm actually standing on the galaxy right there, and let me zoom back in. Yep, that's my avatar, how other VR players see me, while other participants just join through a regular video call. And the way we work with this, we take a video stream and then we cut it into individual pieces and place each piece into a virtual window, and then we can move those windows around to create an amphitheater of different shapes, the way it would fit into different situations in our experience. Now, the beauty of integrating a video messenger with virtual reality content is that I, as a teacher, can be in virtual reality and I can show different things in 3 dimensions to other people, different 3D assets, 3D animations, 3D environments, and basically interact with the things like I wouldn't be able to interact in a real life. But on top of that, there is an advantage that we can do whatever we want with the camera, and we can program the camera to specifically follow a presenter in a particular way. For example, fly away and show from a bigger distance, or zoom in and react to particular events and show things that need to be shown at the particular moment. For example, let's come here and try to create a star system. I'm grabbing this nebula and now I'm accelerating it, and you can see how the camera shows to the audience exactly me and the nebula. And in our experience, we basically use our controllers as time machines to accelerate developments of things. And here we create a protoplanetary system. We accelerate development of a nebula, and then after it pushes away an energy, boom, and it creates a star system with a nice looking hot blue star in it and a mini lab around this area so the students can work in teams. Let's step in, and inside you can see a protoplanetary disk, and you can see the amphitheater of our video messenger from which students can see the experience. And as I start doing things in the mini lab, like for example accelerating development of protoplanets, the camera shows exactly what the students need to see at that moment, just because this camera is specifically programmed to react in a particular way to particular situations. You can see my colleagues over there. One is a drone on a cell phone, and one in VR, present as an avatar, and everybody else is joining through a video messenger. Now let's create some more protoplanets. Here we go, and as we create more protoplanets, the next thing that we need to do is actually go ahead, teleport on the disk, become small, and take the protoplanet into our hand, and then launch it on an orbit. We can change angle and speed of the protoplanet so it affects the orbit, and then boom, and the protoplanet flies away. And look at what happens on the screen for the students as it goes away. The camera continues to follow the protoplanet. It shows how it gradually becomes a planet as it collects more dust and debris. Let's show our audience. They're over here. Let me step away from the disk. And as you can see, the camera keeps doing its own thing when it stays on order, and then I can always switch it to manual and put it where I want it to be. Let me, for example, put it here, and then use some of the call tools that are available to me at the experience. For example, use annotations. I can take and marker and annotate my video in the experience and say, hey, here is the orbit. Let me draw it better, and here's the protoplanet. And then I can, for example, take this and increase so I can see it better myself, and clean it all. And now, besides annotations, there is a whiteboard tool. I can use it to write in the experience. For example, write some formulas. Let me put something here like let's look at E equals mc square. And I can click whiteboard only, and then the students will see only the whiteboard and only what I'm creating in the video stream, meaning that they will not see my hands or my avatar. It will work just as a regular whiteboard on a regular video call. Now let me turn it off, and you can see the camera goes back into the auto regime. Now, as I've mentioned to you, this experience is dedicated to the creation of stars and star systems. You can see how John and Liam have already created some of the planets here, and they can keep creating until it actually becomes a full-blown planetary system. But let's just go ahead and age the star. Let me start shooting at a star, and as the star ages, it starts growing. This is a particularly big star. It evolves into a supergiant, and at the end of its life, the supergiants, they have a supernova explosion. You can see this like a signature double collapse, and then big shockwave goes all across the galaxy. And if there are other mini labs right there on the galaxy, they will feel how the shockwave just went through them, and they will understand that a particular team has just created supernova. You can see that at the end of this supernova, it created a black hole, and you can see how it even bends light. Now, different stars die in different way, and in this virtual reality experience, we have different kinds of main sequence stars. Now, let's go ahead and create something smaller. For example, let's pick this nebula and start accelerating it. And again, camera shows the nebula and me accelerating it. And here we go, and then the nuclear reaction begins, and eventually we witness the creation, yes, of a star. And yeah, in this case it looks like an F-class star, which is a white star, a little bit bigger, a little bit hotter than our sun. Now let's age it. In this case, it dies a little bit different. You see how faster it evolved because all of us were shooting together. But now you can see how this giant also starts to gradually die. It sheds layers and boom, eventually collapses into what is a white dwarf with nice looking, beautiful nebula around it. So now you can see the advantages of integrating a video messenger with an actual virtual reality content. Here, presenter, in this particular case a teacher, is able to show and interact with 3D assets, 3D environments, 3D animations, and show them with an immediate academic value while having a lower barrier of entry for the participants.